let's get started. I want to begin by introducing Simon Westlake from Sonar Software. Simon is the co-founder and CEO of Sonar Software. His leadership in the development of Sonar, an industry-leading ISP billing and operational support system platform targeting the fixed wireless industry, has been essential in achieving its phenomenal growth. The Sonar platform has been trusted by hundreds of ISPs worldwide since September 2015. They're a much-loved company in the WISP community. And over to you, Simon, to take us through the presentation.
Thanks, Sonit. I appreciate the intro. So thanks for joining, everybody. And I'm going to give a really quick overview of what Sonar is and how it works today. I'm going to touch mostly on the things that I think make us different in the interest of time. But as mentioned earlier, we're happy to answer any questions. And I'm sure Georgette and Harneet will share ways you can get in touch with us after the webinar as well if there's more we need to chat through. Okay, so quick run through of the agenda here. Like I said, I'm going to talk about Sonar at a high level and especially touch on the business intelligence module we launched recently that I'm pretty excited about. And then I'm going to hand this over to Gerrit to talk more about Preseem, both how that works and how it can integrate with Sonar. I'll quickly just launch that off by saying that we've been working closely with Preseem for quite some time now, I think at least a couple of years, maybe longer, and it's a really exciting project and one of the most interesting products that I've seen come into the industry in a while. We had a pretty strong relationship prior to this with a couple of different companies that provided DPI solutions where you could look at different types of applications in the network and build rules around them and inspect what customers were doing in real time. And I think Preseem has really taken charge of moving ahead of all the things that those platforms were doing. It's taken away all the complexity of deployment, and I can't say enough good things about it. So Gerrit doesn't hear me give him compliments too often, so I wanted to at least throw one out there for today.
Much appreciated, Simon.
You're welcome. All right, I'll have to deal with my slow. You want to just move to the next slide, Gerrit? It's a bit sluggish me doing this like this. Yeah, thanks. Okay, so real quickly, like Harneet mentioned, Sonar is a company that's been around for about 5 years. We provide software to ISPs around the world. Majority of our customers are in North America, but we do have customers as far away as Australia, throughout Europe, and in South America as well. We recently changed our tagline to be partnering to make business simple, because we've really tried to transition recently away from being strictly a software company and becoming much more of a partner in your business. And as Georgette mentioned, she's one of our customer success managers, and that's a big team we've been building up lately because we've recognized that you being successful makes us successful and vice versa. And so while the software is a big piece of what we do to try to help ISPs grow, it's not the only piece. We really want to team up with you and help you see success. So Sonar as a whole is a web-based billing platform that has a number of different features, and there's a quick screenshot on the screen here. Down the left-hand side, there's a list of some of the different modules I'll quickly run through. We have a ticketing system, we have scheduling for field work, we have an IP address management tool, inventory management, various mapping functions, a CRM and billing system, and network monitoring built in. And I think all of those modules that we have are pretty exciting, and they're well built and they have a lot of good features, but they're not super exciting, right? Like, these are all things that a lot of other competitive systems have, and they're pretty standard features. So today, I'm not going to delve deeply into what makes us different there, but again, plenty of info on our website. We're happy to talk to you about that more later. What I'd like to talk about are the exciting things in Sonar, I think, that differentiate us and make us different. And really what we've always focused on here, whether it's provided as part of the software or it's provided as part of that customer success engagement we do with you, is to get rid of redundant tasks and get rid of busy work. I think the biggest detriment to success for most companies is lack of automation, having to do the same thing over and over again and figuring out how to scale that. So that's really at the core of everything we do. trying my best here, Gerrit. You want to jump that one forward for me? Thanks. Okay. So our API is a big thing that makes us different. And I think if you are not a super technical person or you're not a developer, you might think, why is this interesting to me? Or, you know, I'm never gonna use this. And I would say, think about that again. As you grow your business, you're inevitably going to run into things that you need to do, or new ideas you have for a product that you want to sell, or some way that you want to compensate a salesperson, or who knows what. There's going to be some idea you have where you need to be able to do something unique. And what an API offers you is the ability to interface with a piece of software and expand it in some way, or integrate it with another platform, or just do something with it that we may not have thought of. Historically, a lot of software doesn't have an API at all, or if it does, it's pretty simplistic. You can do things with it like look at the details of a customer or create a new customer, but not really do something where you have a ton of control over the data that comes back or what the outcome of your request is going to be. And so in Sonar v2, we built a whole new API that's built on top of a technology called GraphQL that was designed by Facebook. And this really gives you more flexibility than I've ever seen in any API in my life to do anything you want with Sonar. I have a explanation on here of just one thing you could do with this API in a single query, which is to get all these accounts with an active status and filter them where the customer's in Milwaukee, et cetera, et cetera. And over on the right, I've compared with our GraphQL API. This whole query could be done in a single request. In our old API, which was a REST-based API, this would have literally taken over 50,000 queries for 10,000 accounts. So it would have required you to do a lot of work on your side to filter it. So we've really done everything we can here to try and enable you to be successful and do the things that you want to do. The other thing that we have built in is this API playground, which you can see here, where you're able to run API requests live in our application and see the response in real time. It's also fully documented inside this playground, so you really don't even have to be a developer to make use of this. You're able to play around with this right inside Sonar and never write a line of code and still get back the data you're looking for. Next thing we've done that I'm pretty excited about is this embedded business intelligence reporting. So this might kind of sound like a buzzword, but business intelligence has become a really big thing in the industry over the last few years. And this was started off by companies offering platforms like Crystal Reports, if you've ever heard of that, back in the day, where you could build reports in a simple interface against a database. And that moved on to a kind of phase 2 of business intelligence, which was companies like Tableau, or on Microsoft's side, they had Power BI, where there was a more of an expansion of where this data could come from and how it could be filtered. And I would say we're kind of in a third phase of business intelligence now, where there's a number of companies that have created even more powerful reporting tools. And we have taken one of these tools and embedded them directly inside Sonar so that all of your data that you have is able to be represented in any way you want. You want to see it as a graph, you want to see it as a pie chart, you want a tabular report. You can represent that however you want. And it's not just about the representation. You can filter it and grab it any way that you want. And we've accomplished this by embedding a product called Looker inside Sonar. And Looker was recently acquired by Google for more money than I can recall, or I think I'll ever see at any point in my life. So I think we felt pretty confident that it was a leading product in the marketplace. The other thing that we have enabled inside Sonar with this is the ability for you to build your own reports. This isn't just about us being able to create pre-built reports that you can look at and then have to call us to ask us to modify. You can actually use this tool directly inside Sonar in real time to build any report you want and share it with whoever you want and modify it yourself. And we're providing the vast majority of this functionality as part of the normal Sonar product. There's a very small upcharge for the report customization piece, which I think is measured in tens of dollars per user you want to do that. And to give a point of comparison, if you go out and get a quote from Looker to deploy this just for your business, I believe the list price is something like $50,000 or $60,000 a year just to get started. So we're pretty excited we've been able to figure out a way to provide this to all of you. And I think this has overcome one of the biggest issues we've always had, which is reporting. It's a very hard problem to solve, and I'm really excited about the way we've done that here. Last thing I'm going to touch on quickly before handing this over to Gerrit is that there's a lot of pieces of Sonar that interconnect with Preseem to make things simple. And this has really been a lot of work that Gerrit's team has done, as well as my team's done, to build these interfaces and link things together. But part of why this has worked so well is that both Sonar and Preseem have a pretty similar view about how to look at a network, how to look at an ISP, and just how things work. And Gerrit's going to show you here in a minute how they look at the network and they figure out who's connected to what access point and who's creating issues on the network, or how they do rate limiting. And inside Sonar, we have a lot of this same kind of data that we can expose, and the combination of these two products just brings you so much more flexibility than you'd otherwise have. So this last screenshot I have on here is an image of what we call Sonar Pulse, and we're about to relaunch this in our new V2 product. And what this will do is inspect your whole network in real time, figure out what users connected to what IP is connected to what switch is connected to what router, and all the way down the chain. And by using the combination of these tools we have and the monitoring we have and all of the technology that Preseem has, Gerrit's going to show you here in a minute how simple it is to troubleshoot some of the issues that I'm sure plague you regularly.
Thank you, Simon, for your informative presentation. We are going to move on to Preseem, as you mentioned. So let's hear from Gerrit as he shares all about QoE, bandwidth management, and much more. Gerrit is the co-founder and CEO at Preseem. He currently leads sales, business development, and client relationships for Preseem. He has many years of engineering management experience, including managing an offshore development site in the Middle East. Over to Gerrit.
Thank you so much, Georgette and Simon, for all that. Yeah, so on this part of the webinar, I'm going to talk about Preseem. We'll start with the general background on quality of experience, how to measure it, how to find issues in your network, as well as optimization, and then we'll finish up with the integration with Sonar. Again, if you have any questions, put them in the Q&A panel, and we'll deal with those at the end of this part. So let's start with a bit of a definition. What is quality of experience? Quality of experience is all about how your customers experience your service. And the main factors going into this are bandwidth, are people getting their planned speed, latency and jitter without having to wait for packets, and packet loss. Now, bandwidth typically gets most of the attention here, but it turns out that latency is often much more important for the fast-fueling internet. If you think about applications like gaming and VoIP and browsing, they don't use a ton of bandwidth, but it's really important that the latency is low, because if the latency goes up, for example, page loads start going very slowly and things like that. And in your customer's mind, that feeling slow to them means a bandwidth or a speed issue, because they don't understand how all this works. And what will happen is then they'll run a speed test, and then they'll complain to you that you're not delivering the speed you're supposed to and all that. And if you can keep your latency under control, and there's many sources that I'll go over as well, you'll find that all those applications run much faster, and you're just going to get a lot fewer calls about slow internet complaints. And really, poor QoE, you can equate that with slow feeling internet. Bits are still flowing, but it's just not feeling fast enough. That's really what this is all about. Now, Preseem is deployed in hundreds and hundreds of networks, all mostly fixed wireless, a lot in North America, but across the world really as well now. And so we have a really good idea now of what some of the common causes are of poor quality of experience in these kind of networks. And what we find over and over again is that shapers or plan enforcement has a really big impact. How you enforce or rate limit your customer's plan, 5 meg, 10 meg, whatever, has a really massive impact on what happens when they max that out. And I'll talk more about that on the optimization side towards the end of this. The next big one is your last mile. Your access points have the most variability, they're the hardest to get right. If you give somebody a 1 gig fiber link, chances are good they're going to get pretty close to 1 gig of bandwidth. With an access point, even under ideal conditions, you're not going to get anywhere close to what the spec sheet says. And then you have to worry about underperforming APs due to interference, line of sight issues, and all of that. And again, we put a lot of focus on this in Preseem because we see so many problems here. The next one is in-home Wi-Fi. If you have managed routers, you can help control that, but it's at least important to understand if there are issues here. Backhauls we see less often, but when it does happen, of course, it can impact a bigger chunk of your network, so quite important. And then even less common, but higher impact yet, high transit capacity, and a special mention here goes to overloaded MikroTiks as well. We've seen some interesting behavior when that happens. So the question then is, how do you find these kind of issues in your network? How do you find QE issues? And if you think about traditional network monitoring, your SNMP, your ICMP, ping, whatever, really important. It's good to understand. You need to understand what network elements are up or down. You need to be able to track certain counters over time and all that. So definitely do that. The problem is that just by looking at that, you don't actually know if your network or those network elements are delivering a good experience to the end users. It's much more of a grayscale than a up or down, black or white kind of thing. And one way to think about poor quality of experience is in terms of bottlenecks in your network. So a congested access point or an in-home Wi-Fi issue are simply bottlenecks in your network that have more data coming in that it can transmit, and they're going to start queuing or buffering data and eventually dropping it. And this combination of queuing, which adds latency and packet loss, is what can result in such a poor experience for the end user together with that lower bandwidth. Now, the great thing is, though, the existing TCP traffic on your network has built-in mechanisms to detect all of this. So for example, if a packet is dropped, TCP detects it and sends a retransmit. You can count those and actually pinpoint where that is happening. And what we find that's most common in this kind of gear, especially access points and things like that, is buffering and latency being added. And you can measure that through something called TCP Roundtrip Time. This requires an inline device, which I'll show on the next slide as well. But basically, the inline device measures how long it takes for a packet to go from it, basically downstream, through your backhauls, your access points, CPE, right through home Wi-Fi to the end user device, phone, Apple TV, iPad, whatever. And then TCP on that device sends back an acknowledgement packet saying, yep, I got that. The acknowledgement packet comes traveling back. And when it gets back to the inline device, you can correlate those two and deduce the latency from that round trip time. And now you know with that data, you know exactly what the end user experience is because you can see what the latency is of the actual customer's traffic as well as the packet loss. Now, note that this is quite different than ICMP or ping latency. A couple of, some examples here. Ping can't go into the home, whereas TCP round trip time, it follows the packet all the way to the end and back again. So even home Wi-Fi problems you can catch this way. Round trip time doesn't inject any traffic, so there's no extra load on your network elements. And last but not least, vendors have a bit of a habit of prioritizing ping packets differently, some higher, some lower, but it's not a good indicator of what the actual experience again for the end user is. So round trip time does a much better job on that. Now, Preseem, of course, does all of that. It does the monitoring side based on those metrics I just explained. There's an optimization side as well. Architecturally, there's an inline device that's a layer 2 transparent bridge. We have appliances. You can provide your own third-party hardware. Basically, you need as many boxes as you have connections to the internet. That can be one, that can be dozens. Doesn't really matter. Whatever traffic each one sees, it collects, it does the shaping on, and it sends all data to our cloud. Our cloud then is connected to the billing system. Now, we can run without a billing system as well, but it is so much easier to have a billing system, especially Sonar. We have more Sonar deployments than anything else out there. What I love about this integration is both easy and it's bidirectional as well. There's elements, Preseem pulls a lot of data from Sonar, but then some critical data from Preseem you can get from Sonar, have an easy link to, and that kind of thing. And I'll show a bit more about that as well. But high level, the key things we need is we need to understand that all the IP addresses going through the box, what subscriber is that, what plan speed do they have, that comes from Sonar, and then a list of all the access points and what towers they're on. We then connect to SNMP or a few other tools depending on the technology to map out what subscribers are on what access point. And the reason that's so important is it helps you pinpoint what the issues are. So if you look, for example, at all the latencies for all the subscribers on a given access point, if they all have the same high latency pattern, and I'll show you an example of this, then you know the whole AP is having issues. If on the other hand, only one or two are high and the rest is low, then you know the backhaul is okay, the AP is okay. It must be a problem specific to that subscriber, typically either a signal strength issue, or if not that, Wi-Fi in the home. So I'm going to show us a couple of screenshots. This isn't meant to be a really thorough walkthrough or anything like that. If you want to learn more, we can do a demo. It's happy to do that. But this particular screen is a list of all the access points in the network. And this is really the starting point for proactively finding where the issues are. Preseem looks at every access point on a 24-hour basis, figures out the peak times, and for the peak times, it takes all those latency samples for all the subscribers and mashes that into one score, the latency score, and then everything is rated as green, yellow, or red. Tells you very quickly where all the problem areas are, your reds, of course. And then we also give you some context to understand, is this access point likely overloaded? Are there too many subscribers, too much data, or is it underperforming? And you can see actually right from the screen, the first indicator is the oversubscription ratio. We basically add all the plan speeds of all the subscribers on that access point that we got from Sonar and divide it by the typical throughput we expect to see for that AP. And I'm going to talk a bit more about that particular metric because it's quite interesting. And this is really sort of a theoretical, how much load can you expect to see on this AP? The busy hours tells you how much time did it spend above the typical throughput we see for this access point. So basically, if that number is greater than 0, you've probably got an overloaded AP. If it's under and you've got a red sector, you've probably got an underperforming access point. And I'll show you a bit more in a bit more detail here as well. The other great thing again about the integration with Sonar here is that latency status, which is a great indicator of the health of the AP, you can actually see from within Sonar as well. So it has a device status, good in this case, and then Preseem, the color coding, the green, yellow, red, you see right here as well. So you see this nicely side by side, which is super useful. So here we're going to dig a little bit more into a typical access point. This one would have been red on the previous screen. And really, again, the key is to figure out why is that? Is it typical causes are either overloaded or underperforming? And so if you look at some of the parts here, the bottom right is a stacked bandwidth chart of all the subscribers. The numbers you see are the subscriber IDs from Sonar, exactly the same numbers. We just reuse those again. So now you can see both the total throughput as well as the contribution of each subscriber, and these are always sorted from highest to lowest. So you could easily find over the last week or month what the heaviest user on that AP is. So maybe that's a good target to offload, for example. The top right then shows you the latency. Again, this is each subscriber has a different color. If there's no data, there's no latency samples either because we measured existing traffic. And in a case like this, you can see that all the subscribers' latency are moving in unison. On the left here, they're around 200 milliseconds altogether, comes down during off-peak, and then back up again during the next evening. This, of course, was before COVID. It's a lot busier the whole day now. But this tells us right away that, okay, there's an AP level issue. So then if you look at the bottom left chart, this orange dotted line is a typical throughput we expect to see for this model access point at this channel width. And so if you look at the legend here, this is a Rocket M5, Ubiquity, of course, at 20 megahertz. At the time we did this in March, we had about 1,264 of those we were monitoring, sort of a crowdsourcing thing. And based on that, we expect to see about 42 megabits of throughput. In this case, when the latency is high, you can see the bandwidth is around the orange line. That probably means it's getting pretty tapped out. Maybe there's a bit of tweaking you can do, but it's pretty busy. If on the other hand, you see that the latency is super high and the throughput is way lower than the orange line, think interference, line of sight issues, alignment, something is holding the AP back from running at optimal performance because compared to everybody else, and it's usually has a pretty big number, it's just doing a lot less well. Okay, so that was sort of the proactive side on finding the issues. You can also use all this data for customer support. So for your folks answering the phones, what we try to do here is give you a bit of context on the top. You can see the maximum plan speed or the actual observed speed. We've seen some metadata like the plan speed, IP address, daily, monthly usage, which we can log all to Sonar. But really, what you're trying to do here is put yourself in your customer's shoes. When one of your customers calls in, you need to figure out, why are they calling? Are they having a quality issue? Is there some kind of bottleneck? Do they need an upsell instead? And really, the two charts at the bottom right show you most of what you need to know. The white line here under latency is the subscriber's latency. If that is in the red, I can almost guarantee you that's why they're calling. There's some kind of bottleneck to track down. So then the question is, why is that? Well, if you look at the black line is the average latency of all the subscribers on that same access point. So basically, if they're both high, like in this case, you've got an access point issue. And whatever your internal workflow is for your company, you just follow that. If on the other hand, you find that the white line is high and the black line is low, you've got a subscriber specific issue. So in that case, check the signal strength. If that is bad, there you go. That's probably the reason. If that is good, the problem is almost always Wi-Fi in the home that's causing this. If you find that both are in the green, have a look at the downstream below. You probably have somebody maxing out their plan speed consistently that just needs a faster plan. And so again, you can really put yourself in your customer's shoes. Another nice integration touch point with Sonar here is you can actually, the screen I just showed, you can jump to that directly from Sonar. There's an open in Preseem button under the account. So click on that, brings you straight there. Again, makes it just much easier to quickly deal with these calls as they're coming in. Okay, so that was the monitoring side of Preseem. Next, talk a little bit about the optimization as well. And I'll start out by saying, we're talking about why that's so important. So if you think about typical shapers, like the simplistic shapers, so MikroTik simple queues, or maybe the shapers built into the radios, they were designed to make sure your customers don't exceed their plan speed, manage the bandwidth on your network, but not to make sure that even when they do that, when they max the plan speed out, that the experience is still really good. And the reason for that is there's a single queue inside that shaper that all your customers' traffic goes through. And if something dominant like a Netflix comes along and maxes that connection out, that internal queue starts filling up and starts buffering packets and adding latency. And we can actually measure that as one of our screenshots with the before and after here. And so now you have something big like a Netflix that's causing latency to be added to all the applications going through that house. So your streaming can impact your gaming and your VoIP and your browsing. And it is that latency being added to everything that can cause such a poor experience, and your customers to call in with, my internet is slow, and you tell them, yeah, but you're maxing your plan speed out, what do you expect? But it doesn't actually have to be that way, because there's literally now fairly recently developed standard algorithms that fix these problems in a really elegant and simple way. And in particular, in Preseem, we use one called FQCoddle. You're welcome to Google it for more detail or ask us for more information on it. I'm simply putting it here in the slide to give credit to the fact that we're using that. And FQCoddle has two major advances over the simple queues. The first one is that rather than having one single shared queue that all the traffic goes through, it looks at every application or flow individually. And each one gets classified as either bulk or interactive based entirely on how much data is going through there. We don't do DPI, we don't care what it is. We simply say, is that a bigger flow like a download or a streaming video, in which case it gets classified as bulk, or is it something smaller like VoIP or gaming or browsing, in which case it gets tagged as interactive. And then what happens is internally the interactive flows and all the shaping that happens on our inline device get prioritized. So no matter how busy that link, you can game, you can VoIP, you can browse like nothing else is happening. And then the remaining bandwidth is allocated fairly amongst all the bulk flows. So if you had a download or an upgrade in a Netflix, they would each get half, for example, so up to 4,096 queues per subscriber. Now, the second big thing that happens here is rather than having this shaper, which just blindly queues a whole bunch of data, something called active queue management, the CODL portion, control delay, it actually focuses on latency rather than how full that queue is. It keeps a latency target. This keeps the latency both low and consistent, so low jitter. So even if you're doing a video conference, you still get a really good experience on that application. And really the beauty of this from an operator perspective, especially together with Sonar, we hook the two systems up, you just turn this on. There's not really any tweaking required. You just need to give it the plan speed. And from your subscriber perspective, even when they've maxed their plan speed out, it'll still feel fast now. A little bit about sort of what we've seen in bandwidth patterns and application patterns over the last few months with this whole COVID-19 thing, of course. The biggest things we've seen is obviously a lot of people are working and studying from home. A lot more collaboration applications, video conferencing, that kind of thing. And it seems like there's new applications almost every day. And this is really one of the things where FQCoddle shines. You don't need to worry about adding new protocol packs or encryption or anything like that. It just sees a new protocol, it just starts working. It doesn't care what it is. And again, it really solves that problem of, your kids are watching Netflix in the basement. That won't impact your important Zoom call. So that works really nicely. The other big thing we've seen is during the peak hours, maybe your access points are busier by 20, 30%, but they're busier a lot more, bigger portion of the day. And so if you've already had access points that maybe weren't quite keeping up, for one, the monitoring is going to tell you which ones those are. And if you do see that and you find that they're overloaded, you can actually put a shaper at an access point level through Preseem as well. And what that'll do is it'll basically proportionally allocate that bandwidth to their plan speed fairly amongst all the subscribers in that AP, drive that latency down. And basically the net effect is that all the large applications are squeezed down just enough with nice no latency that the access points no longer overloaded and delivers a much better experience to your customers here. Okay, so next we'll talk a bit about the integration. Again, this is pretty easy. We've I think Simon, it's been about 3 years now since we had the integration going. I still remembered I emailed you on a Sunday, and two hours later you emailed me back, and you had the integration going a week or two later. So that was pretty simple. But yeah, basically the idea is we want you to put all the information in Sonar. If you have it there, there's nothing you have to do in Preseem. Basically, we'll match the Sonar subscriber IDs, the names, the plan speeds, which then drives the QE plan enforcement. We can log usage back to Sonar again. We can block the link when they're non-active subscribers based on Sonar as well. In the Sonar piece between Pulse and all the other monitoring they're doing, together with the QE-based monitoring from Preseem, you've got a really nice sort of holistic solution here. And then again, some of the reverse integration pieces where you can see the sector status in Sonar, one click to get to our subscriber dashboard, really makes it a pleasure to use these two systems together. Okay, that's it for this part of the webinar. We've got a lot of happy mutual customers between us. Here's a couple of examples. I'm not going to read it out loud, but I'll hand it back to Harneet again here.
Thanks, Gerrit. It is now time for the Q&A portion of our webinar today, and over to Georgette to start asking the questions.
So Scott asked, can you touch on the IPv6 capabilities now and near future for the two platforms? And I'll let Simon and Gerrit answer that question.
All right, well, I'll go first since my name was said first. So we've had IPv6 available in Sonar since the beginning, really. We've always supported it in there, and you can manage IPv6 subnets in our IP address management tool, and you can assign IPv6 subnets to customers. I think the tricky piece with IPv6 as a whole is that there's a lot of people deploying it in quite a lot of different ways, and we're still working on different implementations to try and make that easier. But as a core concept, it's fully available in Sonar today, and we're interested in collecting info from our customers about how they're using it today, so we can keep expanding on that. So happy to chat about that in more detail offline if you'd like.
Okay,
Awesome.
great. I'll give my perspective here as well. So I actually have some good news here. We have IPv6 in alpha now. We have it running in our first site. I know it's been something that people have been looking forward to for a while, and we should have it released in about the next month or so as well. And as Simon was saying as well, as lots of different options. We'll have to add a little integration here and that kind of thing, but our core platform is not able to handle IPv6. We have the integration with Sonar done already as well there. So yeah, the full release will be pretty imminent now.
Awesome. I do have a follow-up question, different question for Gerrit. JD Moffett is asking, how does Preseem work with the LTE platforms like BiCells?
So it's fairly similar. The key is that you can't have just one NATed IP coming out of the node B. We need to, the inline device is going to be outside of that. It needs to see individual IP addresses per subscriber. And then with that, basically it works the same way. Probably the other difference is rather than going into SNMP to do the mapping of subscriber to eNode B, we typically go through a Cloud Core account to get that piece. And maybe Simon can touch on the Sonar aspect of this as well. But for us, it's just a regular subscriber that we get from Sonar.
Yeah, I think from our perspective, it's the same kind of thing. I mean, obviously in Sonar, we have the ability to do provisioning for LTE customers on platforms like Bicells and Telred. But once you get onto the shaping and monitoring side, I mean, we're handing most of that off to a platform like Preseem anyway. So I don't think it's a big impact as long as, like Gerrit said, you can give a unique IP address to each subscriber.
It's a fairly common thing for us, by the way.
Excellent. The next question is from Andrew, and Gerrit, this is for you. If you feed a Micropop off of a PTMP AP, does the Micropop's connected plans get counted in the parent APs over a subscription ratio?
At this point, no. We treat them as separate. So what you basically see is that the child, the Micropop, looks just like a regular AP. Whatever subscribers it has on it, it's there. For the parent one, it doesn't yet get included in the overall throughput. That will change in the future as we keep enhancing our model as well. You can see, we now get the bandwidth from SNMP as well. So if you take, I don't know, Cambium, Ubiquity, Access Point, whatever, you can see the throughput that we see based on the subscribers mapped to it, which don't include the Micropop hanging off of it. And then from the SNMP chart, you can actually see the total. So based on that, you actually can kind of figure out what's happening with that. But yeah, there's some more enhancements coming there in the future as well.
Thank you.
Just a quick question again for Gerrit. Carlos Cardoso is asking, in Preseem, the latency display, is it per minute or per hour?
Neither, actually. It's per 10 seconds. So basically, I'll go into a bit of detail here. We collect, so the actual collection of latencies is very fine-grained. Literally, every TCP round trip time, we collect a latency sample. So we get one, it comes back, we keep doing it again and again and again. And then every 10 seconds, we log all those samples to our cloud service. And so 10 seconds is our native grid that you can see it on. But even within that, you can see what the distribution is of high and low latency samples and things like that. So if you zoom into an hour or less, you'll see the 10-second granularity. As you zoom out more, you'll see some roll-ups to make things faster that maybe is based on a 5-minute grid or something like that. But yeah, our native granularity is 10 seconds.
Thank you.
All right. So James is asking, are these WISP-specific solutions, or will they work with a mix of WISP and fiber, for example?
Okay, maybe I'll start with I'll start on that side and let Simon pitch in as well. So from a Preseem perspective, we really started out with fixed wireless. Every customer we have today has at least some fixed wireless. However, many of them also have fiber, copper, or cable, or whatever the case might be. And I know a bunch of them, have Sonar, for example, and they tend to use both systems for all of that. And the advantage can be a little bit different. The shaping has pretty similar benefits. If you had a DSL or a fixed wireless, for example, the optimization works exactly the same way. If you've already got all your plan speeds in Sonar and all your subscribers in Sonar, nothing special to do, all that just works. We started doing some work. For example, the Ubiquity fiber, we can already map that out. And you'll see more and more as well of us doing that through some of the turnkey stuff for the non-fixed wireless. That's really the biggest thing we're working on. We have a very turnkey solution for the fixed wireless gear. Some of the others, the shaping just works. Maybe mapping to a DSLAM or a OLT, whatever the case might be, needs a bit of manual work at this point.
Yeah, I mean, from our perspective, even though on Sonar's side, we started with the WISP industry as a focus, mostly because it's where I've been for the last few years and it's what we know well. At the core of Sonar, I mean, there's nothing super WISP specific in there even. We've always built it as an ISP solution, and I think a lot of quote unquote WISPs out there are really doing other things as well. We see a lot of fiber deployment, and even we've started to see a lot of DOCSIS cable deployments recently. And I think to me, that's one of the things that I always liked about Preseem as well. And hopefully I'm not throwing Gerrit under the bus here, making him do things he doesn't want to, but conceptually, all these networks are pretty similar, right? As an aggregation point that customers all flow to, and that's generally where the bottleneck is. And in a wireless ISP, that's an AP, and a DOCSIS network, it's a CMTS. And so I think, I mean, the only inhibiting factor on Preseem's side really is just building an integration to that aggregation point, right, Gerrit?
Absolutely.
I mean,
Yeah, 100% correct. Yeah, that's exactly what it is. It is, yes, bottlenecks, choke points, all of that. We've seen them. We can already map it as at the ubiquity fiber. It looks very similar, and so we're just going to keep on working on some of those integrations as well.
Yeah, and I think for us, I mean, the rest of what you need to do for an ISP is pretty much the same no matter what you're doing at the high level, right? So I think we always want our customers to feel confident that they can go explore new technologies, and that Sonar is not going to be a bottleneck there.
Yeah.
Awesome. I'm going to quickly ask a question from Cody Anderson to get it. Can Preseem see traffic inside an MPLS tunnel? Brackets, can the shaper be placed with MPLS tunnels from APs flowing through it?
Yeah, there's a few constraints. It needs a 10 gig. So it depends a bit on what network interface you're using. The Intel 710, which all of our appliances use, will do it. So on 10 gigs, yes. We can do 0, 1, or 2 labels we can skip over, and you have to have non-overlapping IP space to do it. But with those constraints, it does work. If that doesn't work, usually we can be deployed outside of the MPLS instead.
Okay, so as an additional question for Gerrit, where do inline devices need to be located in the network? More central or more distributed?
It depends a little bit on what your network looks like. So the first concept is all your traffic, at least the part you want to manage and optimize, needs to go through exactly one inline Preseem device. And some of the other constraints are you want to make sure that if you have any NAT, we need to be on the downstream or the private side of that, so we can see individual IP addresses for every subscriber. And then if you do have multiple boxes, it's pretty straightforward. Whatever traffic each one sees, it does the monitoring for, sends the metrics to the cloud, and it shapes that traffic as well. If traffic moves from one box to another because of a failover, that's all fine. The main constraint to think about is with multiple boxes, you want to make sure that generally the traffic for one subscriber goes through one box. You don't want to have like half going through one box, half going through another, because if they were on a 5 meg plan, for example, each box would let 5 megs of traffic through. And so if you can do those constraints, it's easy. If you're not quite sure how to do that, we've got multiple solutions architects now where we're happy to review your network setup and make suggestions on the best way to deploy it.
Awesome. Gerrit, if you can answer some of the other questions briefly. I have one from Rico. How bandwidth intensive is Preseem's data collection model?
Yep. Okay. So there's two parts to that. In your network itself, because we're just measuring the existing traffic flowing through, we don't inject anything. There's a few SNMP calls to your access point every 15 minutes to get that mapping, but that's not really anything substantial. And then the traffic going up to the cloud, it's roughly 0.1%. So if you have 1 gigabit of bandwidth of data flowing through for your customers' traffic, you'll see about 1 megabit of metrics going up to our cloud service. So it's pretty modest.
Excellent. Can you touch on how bandwidth control works with multiple internet peers that are geographically dispersed?
Yep. Yeah, so I touched upon a little bit upon that in the previous part as well, right? So in that case, you would generally just have multiple boxes and you'd have an appliance or a server in each of your internet peers. The main thing to think about, again, how the traffic is routed. And again, if you have something more complicated, let's set up a call with one of our solutions architects to review the best way to do that.
Awesome. I have another question for you. Cody Anderson is asking, how well does an AP level shaper work with the Cambium Medusa AP? Wondering how it handles MU, MIMO, etc., where total throughput can peak out for some, but not all subscribers on an AP.
Yeah, this one is really interesting. So I'll start with the monitoring side. So the first challenge you have at an access point like that is it's actually quite difficult to tell with most tools if they're maxed out or not. So you might be used in the Cambium world to look at frame utilization. That doesn't help you all that much with the Medusa, because as soon as one of those channels maxes out, the frame utilization goes to 100%. Then you can look at the multiplexing gain to see if you're at 1, 2, 3, 7. You probably won't see in practice, but you still won't have a really good idea of if you actually need a shaper or not. And so if you look at the latency charts that we do, it actually becomes fairly obvious, because as soon as one of those subchannels maxes out, you'll start seeing higher latency for the subscribers and know there's an issue. The shaping is actually quite a tough problem to solve. I'll be open about that. We've had some conversations with Cambium to figure out a way to synchronize the two systems, but it is an insane amount of data to try and sync to. So we can certainly decrease the overall amount of traffic going through the AP, which will help you. We can tell you where the problem areas are. But if all you have is one of those spatial channels is having major problems, yes, it is difficult to pinpoint just that. We simply can't get, because it changes so fast, an accurate mapping of subscriber to a subchannel there.
Excellent. And last but not least for this round of Q&A, does Preseem support Mimosa APs, more specifically around the AP level shaper?
Yes, we do. So we have the ability to map out subscribers to access points at Mimosa as well. That works quite well. And then the shaping is just the same thing. We know what subscribers are on it. Again, I guess the thing to keep in mind is it's not like we tell the Mimosa what to shape. The shaping happens in the inline device. We know what subscribers are mapped to that access point. You set an overall rule in our UI for give it 40 megs, and the collection of subscribers on it together will share that 40 megs. So yeah, Mimosa is easy to do for us.
Excellent. And we want to thank everyone for joining and for all of the great questions. If we didn't get a chance to answer your question, or a couple more pop up as we're finishing up, we will follow back up with you. And we really want to thank Simon and Gerrit again for their presentations. We appreciate everyone's time, and we hope you have a wonderful day. Thanks for joining us.